Alright, this is the Constant Velocity Lab. I'm John Bratz. The problem was to analyze the motion of an object that maintains a constant velocity. A constant velocity would imply zero acceleration, and that's because acceleration is defined as the derivative of velocity with respect to time. So if velocity is constant, then the derivative is zero, and so acceleration is zero. And Newton's second law, which says F equals ma, says that if acceleration is zero, then force is zero. So constant velocity implies a net force of zero. So I analyzed the motion of a marble falling vertically through a tube filled with water. I took a video with my iPhone. You can see that at first glance it looks like the velocity is constant as it moves downward. So if the velocity is constant, then you can just beforehand speculate on what kind of forces are acting on it. You know that gravity is pulling it downward, and you know from the water that there's a drag force opposing its motion upward. So somehow there's a combination of these forces, and these forces may or may not cancel to give a net force of zero, but that's what we're trying to find out. So the video analysis, my camera was 30 frames per second. I chose my origin to be the bottom of the tube, and I rotated my axis so that the y component corresponded with the dimension that the marble was moving in, so the y direction. If I had rotated it, then I would have gotten data from it would have showed motion in the x and y components, and it would have been hard to see that there's really only one dimension of motion here, and it's only going in a straight line down. So to make that apparent, I aligned the axis with the motion. My known length of tube is 1 meter, so that's how I define length. And the graph of the data shows that the slope is approximately constant, and it's at negative 0.19 meters per second. So that's the average velocity as it falls. The initial velocity, I averaged it over the first 0.2 seconds, so the first few frames. I figured the first 2 frames, if I had used that, wouldn't have been very accurate just because of the noise that came from me picking the points, and just because the marble's so small compared to just the whole frame, and the pixels are all close together. Anyway, the initial velocity average over the first few frames is negative 0.19 meters per second as well. So for the computational VPython model, I assume a net force of 0 and see how well that corresponds. I plug in an initial position of 0.7490, an initial velocity of 0, negative 0.190. My delta t time step was 1/30th, just to correspond with the frame rate, and t goes from 0 to 0.733. So green on the graph is the observed data, and the red is the model, and they correspond very well, which allows us to conclude that our assumption of the net force being 0 was correct, and it was a good assumption to make. So since our assumption that the net force on the marble was 0 gave rise to a model that matched the data, we can reasonably conclude that the gravitational force and drag force that acted on the marble canceled each other out, and gave a net force and acceleration of 0, which means constant velocity. So there you have it.